It can be pretty handy to label the HKL lattice planes in Vesta. So I've got the silicon diamond cubic crystal structure here as an example. And if I want to label some planes, I go up to Edit, down to Lattice Planes. I get the Lattice Planes dialog with an empty table, so nothing here yet, which is why we don't have any labeled planes. If I click New, it's going to default to the 100 plane, and it's going to default to this lime green. So I can choose whatever color I want. I can choose the shininess of this thing, the specularity of this thing, and whatever you want in terms of the shades to differentiate. This can be handy if you're labeling more than one plane and you want to see how they are interacting with each other. If I want to add, say, a second plane, and maybe I want to add a plane right in the middle of the cell, halfway from the origin to the 100 plane, well, I would know that if that's intercepting halfway into the unit cell, then that would be the 200 plane. So I can click New, it's going to default to the same 100 plane. So I'm going to type in 200. And when you do that, it's Vesta, for whatever reason, is going to multiply the interplanar spacing by 2. And if you take the 200 plane and you multiply it by 2, you get the 100 plane. And so let's just put that 1 times whatever the interplanar spacing is, and that should update. Yep. And so now we have a plane, and I can change the color of this thing. And so now I have the 200 plane in pink, the 100 plane in yellow. And I toss in the 111 plane here in green just for good measure, since that's the highest density of atoms in any FCC or diamond cubic lattice. So one more handy thing that can make it nice to visualize interplanar spacings or d-spacings is right now I have the pink plane, that's the 200 plane that we labeled before. And right now it's at 1 times that 200 distance, 1 times the interplanar spacing. So if I want to label, say, 2 times that distance, which would be the plane, the next plane in that same distance series, I could add another plane. Let's change the color just to make it clear. And now for this second plane, let's multiply that by 2 and then enter. And you can see now I have my 200 plane. So here's my origin. Here's my 200 plane. Here's the next 200 plane, spaced 1D spacing. That's the 200 interplanar spacing. This is a really helpful way to sort of visualize, because it may not be completely intuitive the first few times that you're thinking about this, but the 200 plane is coincident with the 100 plane, which makes sense. So if this is the origin, here's 200, here's 100, but this distance from the origin to the first 200 is the same as moving another 200 distance in this plane. So the 200 is also the 100 plane, but the 100 plane is not the same as a 200 plane.